Hello everyone and welcome back to the channel. Long time no see, and first things first, I wish you all a happy new year and the best for 2026. Now in today's video we have a controversial subject, and that is if we should use dielectric grease on electrical connectors in our cars or generally. It's a habit I had forever actually, and after a viewer pointed out that this is not conductive and will hurt the connection, it is a pretty good idea to do a video about it, as I saw that no one has tested the actual resistance change when you're using dielectric grease. I mean, Scotty Kilmer says that you should put it everywhere, although he said that it is conductive, and that is not true, of course. So for our test, what we've got here, we have our power supply set at 1 amp, so it will give us an easy calculation with Ohm's Law. Here we have the multimeter at its lowest millivolt setting, and what I've done here, one pair is connected from the power supply to the connector, and the multimeter is measuring volts, so it would be easy to measure our resistance for this connector. Actually, this one is for the cables as well, but as this is common in both our tests, it would be easy to see. Another I'm going to test are these bullet connectors. It is a banana 4mm, but it is used in remote control stuff, as well as this one, which is called XT connector, I think. And that, as you can see, these are very high power connectors, and as you can see, this is how it connects. Let's start our test. I'm raising my power supply just a bit down. There we go. So at the moment what we are seeing is 33 millivolts. So that tells us that this connection has 33 milliohms or 0.033 ohms resistance. I will wear my gloves for this test. I mean, I've been using dielectric grease from forever actually. It was in my very first video, I think, of the Mazda RX-8, where I did put the electric grease in the seat connection, which is the airbags and some other stuff. And I'm also interested to see the result. Oh, and of course, one more connector I'm going to test is this very common one. Now for this one, we have 33 milliohms. I will try not to disturb anything. As you can see, it changes, so now we have about 25 milliohms. I've disconnected, and now I'm going to use quite a bit. Don't know if you can see that I have squeezed quite a bit there, and this is what I like for stubborn connectors or that are not very easy to connect. It always helps slide in very well. And there we go. No change at all, 23 milliohms at the moment, so we really get even lower resistance than before. I'm going to touch those disconnected and connected again, and as we can see, at least with this connector there doesn't seem to be any difference. I don't remember for how much these JST connectors are rated for, but it doesn't seem to make much difference. Let's get to the next one. So this is like this. I will slide it all the way in. And we will get it straight there. So I know not the best view here, but it is what it is. We have our crocodile clips straight on there, and let's, of course this connector is very high amp rated, and you can see only 4 milliohms resistance for this one. Now I will try to disconnect it. It won't be easy. There we go. And I will totally stuff all, as you can see. It's almost covered. Now let's put it inside here. Some of it has squeezed out. And there we go. Just a tiny bit higher, but I mean that may be also from, you can see here, so 3 to 4. Really I cannot say in those as low. There you go. Now it has gone down. At such low resistances, I mean, I don't think it makes much difference, as you can see. Let's test our next connector. And should we go for this very common one? Yes, we are. I want to remove the insulation. That doesn't look very quality wise. So I am afraid I will have to crimp a wire on this one once. So we are back with, let me put my second glove as well. I am back. Unfortunately, I couldn't find my proper crimper for this, but they are both holding quite good. In this situation, we will also measure the wire resistance and the crimp resistance, but because it is the same, it won't make a difference for our experiment. It is a common parameter for both. It is, maybe it's our cables, not that bad. 14 milliohms, quite good actually. Let me unplug it, move it again a bit, so just to see that we get the same result. About 14 milliohms. Let me get the volt down. Now I will try to cover, don't want to throw away all the touch points. I don't know if you can see from the distance, but I have covered it all, so it slides much more easily. And let's crank our power. We got a 1 amp, and very interestingly we have a lower resistance value, 10 milliohms. That's pretty amazing, and that's the kind of connectors I use this. Let me try it again. Yes, 10 milliohms. So as you can see, it doesn't really make any difference. It makes it even a bit better, as I always thought that the grease gets displaced from the pressure parts, but it does slide easier, and it protects, of course, which is the #1 reason, from moisture, etc. So let me put this down, and we go to our very last one. And that is this XT connector, which of course is a high amperage part. I don't know if maybe the spring there is missing, so I will test this piece here. Let me put sorry, nope. So is this the crocodile clips? Of course are not the best for this thing. Let me try to grab that a bit better. Oh wow. So we get about 100 milliohms with this one. Actually, this might be a bit corroded. I think it was used. So actually it is the crocodile clip that doesn't make such a good connection. So this experiment I don't think it will be really. Let's try it again. So much better, about 40 it goes up, 44, 45, and let me put some grease there. So I will put grease here on the contact point. There we go. Plug it in. Oh no. Let's give it a go. So at the moment it does look higher, but of course we are not very sure, oops, if that is the, okay, let's go again. Once more, about the same and a little bit 6 milliohms. So I mean, that sells it for me. I will continue to use dielectric grease on my connectors and plugs and pins. It doesn't seem to do any difference. Maybe it is a bit better with the dielectric grease, and of course we do protect from corrosion and moisture and etc. Tell me in the comments what you think. Is it worth using dielectric grease on the connectors, or should we avoid it? Please hit the like button if you found this video interesting and consider subscribing for more. Thank you for watching and see you on the next one. Bye!